Hello, welcome to Jet Mathematics. I remain your host, Milton Ebiwari John. Still on the series of laws of indices. Today, in this video, we'll be looking at two laws. In our next video, we'll look at some other laws. So in this video, we'll be looking at the law a raised to the power of minus m is equals to 1 over am. A must not be equals to 0. Okay, so when you have an expression like this, you can translate it to this form. A special case of this is when you have a raised to the power of minus 1. It's a special case. You just write 1 over a. So this is a special case of this form. You can take note of this. Okay, and then a kind of variation on this is when you have something like 1 over a raised to the power minus m. This will give you something like a raised to the power of m. So you can also take note of this result as well. So if you have an expression like this, you can write it in this form. Okay, so these are just variation from what we have here. This is a special case of what we have here. Then manipulating this from this law, we can get this. Okay, then if we have another law, say a over b raised to the power of minus m, then we can say this is, we interchange this to b over a raised to the power of m. This also has relationship with this law. Okay, in terms of how this was derived from this, we'll have to use this law to do that. Okay, but we're not showing that in our example. In this video, we are just going to apply the laws in solving problems. Okay, so all you need to do is to try to remember these laws. Okay, so our first question here says 5 raised to the power of 3 divided by 5 raised to the power of 2. We're asked to simplify using index law. Now you see here they have the same base, 5, 5. Remember our law from one of our videos on the laws of indices, part 1. We have that a raised to the power of m divided by a raised to the power of n is equals to a m minus n. So try to remember these laws. So now we'll apply it here. We'll say this becomes 5 raised to the power of 3 minus 5. The powers are subtracting. They have the same base and division, and they are divided. So you have this. Okay. Then this gives us 5, and then 3 minus 5 is minus 2. You see that? Now we're going to apply this law. So applying it here, we'll have this the same as 1 over 5 raised to the power of 2. You see that? Just applying this law, a raised to the power of n equals to 1 over am. So this gives us 1 over 5 raised to the power of 2. So this gives me 1. 5 raised to the power of 2 is 5 times 5, and that gives me 25. Very simple. So here you see we apply law from our previous video, laws of indices, part 1, and then you get this, and then you get all of that. So if you have not seen our previous video, you can as well go back and watch indices, laws of indices, part 1 and part 2. This is part 3, and in our next video we'll be looking at part 4. Okay, let's see the second example over there. This is quite easy. First, let's see, we'll change this to an improper fraction. It's a mixed number here, so let's change to an improper fraction. So 3 times 1 is 3 plus 2 is 5. So we have 5 over 3 all raised to the power of minus 3. Okay, so very simple. This is now looking like this. All we need to do, we interchange the denominator and the numerator, so this becomes 3 and this becomes 5 raised to the power of 3 as we have in this law. Okay, so we are done. Remember in our laws of indices part 2 in our previous video, we say that a over b raised to the power of m is same thing as a raised to the power of m over b raised to the power of m. Right? Remember this law? So we can use it here. So this becomes 3 raised to the power of 3 over 5 raised to the power of 3. And this finally gives us 3 raised to the power of 3 is 27. That is 3 times 3 times 3 divided by 5 raised to the power of 3 is 125. So this is the end of the solution. Please don't forget to like, to share, and also to comment on this video. Okay, and as well follow this page for more interesting topics and examples relating to mathematics problems. Alright, thanks for watching. See you in our next video. Bye.